McLaren, are you going to start with this one?
I think so. Right, welcome. We're going to do electrolysis solution. Now we have done copper 2 sulfate solution, and now we're going to look at sodium chloride solution.
Great.
Now the formula of sodium chloride is NaCl. It's aqueous because of the solution, Dr. Bourne.
So, could you tell us, Miss McLaren, what are the ions that will be present in sodium chloride solution? Because the first thing you have to do is write out all the ions present.
I think I might be able to help you with that,
Good.
Dr. Bourne. So we have sodium plus, chloride ions, and since we're dealing with water, we have hydrogen ions and hydroxide.
Right, so
Easy.
first thing, write out all your ions. Second, you've got to work out what will be attracted to the negative electrode, which is the cathode. We know opposites attract, so what will it be, Miss McLaren?
Well, they will attract the cations. You remember that expression? Na plus and H plus, Dr. Bourne.
Excellent, that's getting easier now. Now we've got to think about the positive anode. So which ions are going to be attracted to the positive anode?
Again, it will be the anions, and the anions are negative. So you're going to be dealing with Cl minus and OH minus, otherwise known as hydroxide.
Good, so this is going extremely well. Now we know what's attracted, but we've got to work out what will actually be discharged at the electrode, and there are very special rules for this. Miss McLaren, what will be discharged in this case at the cathode?
Well, you look at both positive ions, and then the order of preferential discharge at the cathode. We look at the least reactive ion, and in this case, it is hydrogen ion. So the hydrogen ion will pick up electrons from the cathode, and it will turn it into hydrogen gas.
Lovely, so we can do the equation for that. Now we know that's very important, Miss McLaren. You wrote a little 2 there. What does that signify?
Now, that indicates it's a diatomic molecule, i.e. it goes round in pairs.
So that's 2 atoms bonded together.
That is correct.
So if you've got 2 atoms there, what must you have on the other side?
Well, if we've got one hydrogen ion here, we have to multiply by 2.
Lovely.
Now that means overall it's 2 positive, which means it needs to remove 2 electrons from the cathode.
Lovely. So the hydrogen ions are going to gain 2 electrons, and if you gain electrons, that is called
Reduction.
reduction. So the
Dr.
hydrogen ions are reduced.
That is correct.
Lovely. Good. So I think that's it for the cathode for the moment. Let's look at the anode. Here we've got chloride ions and hydroxide ions. What's the rule here, Ms. McLaren?
Well, the rule is any halide is discharged before hydroxide.
Now, what are the halides?
Halides are the negative ions of the halogens. For example, fluoride, chloride, bromide, iodide.
Okay.
And in this case, we've got chloride. So that's going to actually give its electrons to the anode. And in doing so, it will turn into the element chlorine, which is also a diatomic molecule, Dr. Bourne.
So 2 atoms bonded together. So here, the chloride ions are losing electrons. So
That is correct.
could you complete this equation for
Well,
us?
if you get 2 chlorines here, you need 2 chloride ions. Now, overall, that's 2 minus, which means it will lose 2 electrons. So you generally put the electrons here.
Okay,
So
so
you
it's
can
now
see-
balanced.
That's correct. And the chloride ions have lost electrons, which means to say the chloride has been oxidized.
Oxidation is lost. Marvellous. So we know what's attracted, we know what's discharged, we know the equations. What are the observations going to be?
Well, the observation is what you see. So in the case for the cathode, hydrogen gas, now that's a colourless gas, so you'll see effervescence, bubbling, but it's colourless.
So
you'd
bubbles
see
of colourless gas.
fizzing, bubbles. I think I can spell this one
So
correctly.
either of those are correct.
Oh,
Fizzing bubbles of
colourless.
colourless gas.
Gas.
Okay, marvellous. And what about at the anode?
Well, chlorine we know is a gas, so you will see fizzing, difference here is chlorine is a yellow-green colour.
Okay.
So you have to mention yellow-green.
You must
gas.
put the colour in. Okay. Bubbles of a yellow-green gas. Marvellous. Well, that wasn't too difficult.
So I think this has been a gas octagon.
Oh, very good, Miss McLaren.
Thank you.
Okay.